Hi everyone, and thank you for watching this video. I'm Olivier and I'm a program manager in the Azure IoT team. And the video you're watching is about enabling edge computing with Azure IoT Edge. What I'm going to do is actually tell you why and how we've developed Azure IoT Edge, which is this new feature of Azure allowing you to doing edge computing. I will talk a little bit about the concepts, and then I'm going to jump into a demo showing you how to get your feet wet with Azure IoT Edge. So as you might know, we're actually riding a wave of, or a series of waves of innovation, and IoT and Edge are actually feeding in these waves. The first one is the cloud, which is like globally available, infinite compute and storage. Now with the addition of IoT, you can harness sensors, devices, and all their data to get insight out of them. Edge actually brings that intelligence that the cloud is providing all the way down close to the devices. We'll talk more about how it's done with Azure IoT Edge. And all of that, the combination of that cloud intelligence and edge intelligence with the IoT basically connecting the two worlds will allow you to build very advanced artificial intelligence systems. It's often also difficult, and that's why I want to actually spend some time on, to understand when do you need cloud intelligence and when do you need intelligence at the edge. The thing about the scenarios you can implement with intelligence in the cloud, in an IoT solution. You can do remote monitoring and manage remotely devices, machines, factories, and things like that. The fact that you're in the cloud, you can actually merge data coming from multiple IoT devices. You also benefit from that infinite compute and storage, where you can train very advanced machine learning algorithms and other AI tools. So now when it comes to the edge, the reason why you want to use intelligence at the edge is to benefit from low latency, tight control loops that require near real-time response. You also can benefit from translating protocols, connecting devices that normally wouldn't be able to access the internet. You can also normalize data, make it available for other systems and solutions. Last but not least, because you're on the edge, because you are on your property, you can actually guarantee that the data is staying there. And so you actually are working towards privacy policies, and it can protect your IP as well. So Azure IoT Edge implements that intelligence at the edge, leveraging that intelligence in the cloud in Azure. And the way it works actually is based on a runtime first. That runtime, running on the actual device, is providing some very important services. The first one is actually to manage connectivity and the security for devices that eventually would not be connected to the internet. Devices that would actually talk different types of protocols like BACnet, CAN, or Modbus. Another one is the multiplexing capability. So these devices at the edge, behind that edge device, now can be seen by the cloud as unique devices with their own identity. Last but not least, you can leverage that edge device to store and forward. If you're offline and your solution, your factory floor, your ship or whatnot, cannot have a connectivity, the IoT Edge runtime can actually store the data, the events, the messages, and then forward to the cloud next time you're connected. The runtime itself is designed not only to offer these services, but also to manage what we call modules. The concept of module is very important in IoT Edge. Modules, they add capabilities to the runtime. Each of them, they form an action. It's a piece of software, a software entity with a role. You can change these modules and create your own processing pipeline for the data so that you can solve your end-to-end scenarios. Think about converting data from one format to another one, doing some filtering on the data, and maybe applying some more advanced algorithms. Today, the modules on IoT Edge are based on Docker containers, making it super easy to package them and distribute and also run them on various types of platforms, Windows, Linux-based. You can also write your own custom modules. We'll see that you can leverage some of the Azure services, such as Azure Functions or Stream Analytics or machine learning, but you can also build your own code with the language of your choice. So let's see how that works, in a very simple scenario. And I'm going to show you how to actually put together various modules to implement that data processing pipeline. The idea here is to connect a device that talks a protocol which is not internet compatible. The idea is to create a first module that will ingest data from that device, translating the protocol the device knows. Then the data is passed over to another module that does the formatting of the data so that it can be consumed very easily by cloud services. The IoT Edge runtime is used to connect to the cloud and send data up to Azure. Another scenario that the modules actually will help with is to do what we call the cloud offload, running the cloud compute services onto the edge. So these services that are in the cloud today, they provide that artificial intelligence, near real-time analytics, machine learning algorithms, Azure functions to do serverless analytics on data. So modules actually, they provide that true edge analytics by running these Azure services down there on the devices. And you can also imagine that beyond the Microsoft Azure services, you can also leverage an ecosystem of third-party edge services. If someone has developed a killer library for doing image treatment or sound analysis, why not using that code into a module onto Azure IoT Edge and add that scenario to your IoT solution? So here's how it looks like, taking the previous scenario of data being translated and filtered before being sent into the cloud for its actual analytics. Here's how it would look like if you actually were able to run these analytics protocols or models down there on the edge. So here in that scenario, we have the notion of ingesting the data, we have a module that will format, transform the data, and then we have the machine learning job that has been created and trained in the cloud, running on the edge device to do the analytics. Then Edge runtime will send the insights and not a whole bunch of data up to the cloud. You save on lots of bandwidth, and you can leverage that machine learning algorithm, the one trained in the cloud, down at the edge on a device. Another thing which is really important is the ability to configure and to monitor your IoT Edge device from the cloud. This is where the IoT Edge runtime plus Azure IoT Hub, which is the cloud gateway for devices, when you use them together, you can have that full control, that configurability, and monitoring of your devices in the field. So you will configure a workflow from the cloud, say, hey, I want to have this kind of module on these devices, select and target the devices, and then automatically deploy when devices come online. Last but not least, once your system is deployed, Azure IoT Hub will allow you to monitor the IoT Edge devices that are in the field. Once again, with the same scenario as previously, you have your IoT Edge device, and before you actually can run this cloud intelligence on the edge, here's what you have to do. You interact with IoT Hub in order to create this configuration for an edge device. You target the device you want to deploy to, right? Basically configuring that device. When the device comes online, the Edge runtime will read that configuration, will go get the modules from the cloud, will download them, and will run them on the IoT Edge device. And now you have your full pipeline implemented on the device. With having just interacted with the cloud, you've not tinkered with the actual device, it's just running the actual IoT Edge runtime, and it gets all that configuration that you can now change, update, and reconfigure from the cloud through Azure IoT Hub. Let's see a demo of how that looks like. So what you're looking at right now is the Azure portal, and I'm actually looking at an IoT Hub blade here. And in the blade now, there's a new entry called IoT Edge Explorer. In this one, I have prepared and created a little edge device. I just actually created a new device. And in this device, what we'll do is actually start deploying modules. So I'm going to prepare a configuration for that device by selecting new modules. And so in my list of potential choices, here I could import modules that would be based on Azure Stream Analytics or machine learning or Azure Functions. In our case, I'm going to actually import a custom one. The custom one has been actually developed. It's a sensor simulator that we have available for you. And what I do is I point to a Docker container image. As simple as that. And here I have configured my first module that I want to have deployed on my device. What I want to do now is create a second module that will do the filtering, that will do the transformation of the data before it's sent up to the cloud. What it will do is create a new project, and we have some command lines tool to help you do that. That is a custom module for IoT Edge. And so that template actually comes with all you need to get started on IoT Edge module development. This one is a C# based template, but you can actually also use other languages. In this template, I've added some code. I basically set what we call a temperature threshold, and you can imagine what I'm going to do with that. I'm going to receive data from the first module, which is simulating data from a sensor, and I'm going to filter the data based on that threshold here. When the module receives data, it will execute a function, a callback, which is called filter message. And so the filter messages callback, let me show real quick what it looks like. What it does is basically gets the message that it received, reads by deserializing the message, which happens to be JSON, and then if the value of that temperature for the machine is above that threshold, it's going to actually send that message out on its output 1 output. Once I have created my project, the tools that we have in this case embedded into VS Code as an extension allow me to build that IoT Edge module. So I'm building the actual Docker container in a couple of commands. First, I'm exporting the full .NET Core application, and then I'm doing a right-click on that Docker file, which is part of the template, and I can build the IoT Edge module Docker image. And in order to do that, I need to point to the actual published folder that's just been created, where the binary for the application and all the dependencies have been pushed by the tools. Now it's asking me for an image name, and that image name basically is my Docker registry plus the repo name. For those familiar with Docker containers, this is a nice way with Docker Hub or the Azure Container Registry to publish and make available these Docker containers. So I'm selecting that name, which is basically the OBlock registry, and I use the name filter module because that module will be a filter. From there, basically, the tools are creating that Docker image and they're pushing it onto Docker Hub. Now that I have an image that's been created, what I can do is add this new IoT Edge module onto my configuration. So I will actually name that new module filter module, sorry. And the image is the one I just pushed onto my Docker Hub container registry. So it's called filter module latest, right? Eventually, I could set some options. I could set a device twin, which I don't need right now, and I'm going to hit save. And then I will do a next and do a bit more. What I need to do next is prepare for a routing configuration. The actual Edge runtime is able to bring messages from one module to another one. That's the one that actually is doing the routing between the modules. And I do that setup during that configuration. So let me set up the route by just replacing that code here with this definition. So here it's super simple. I have a first route that says that the messages that are from the temp sensor module on output called temperature output would go into that brokered endpoint, which is the filter module input number 1, right? And then I will send the messages that are on the output 1 of the filter module to IoT Hub, and that's called upstream. So this is as simple as that, defining these routes on that device. Once I've done that, I can review the full configuration for that device and I can submit. So I had prepared a configuration for an IoT Edge device which is registered, but for now nothing is running. What I need is to start the runtime on a device. And what I have here is the actual runtime that is provided with tools. And the first action is to actually set up that runtime. We have documentation to do that, but in a nutshell, I'm setting it up so that it connects using that device ID and credentials that are set in IoT Hub. So after setting it up, what I will do is as simple as starting IoT Edge CTL start, which is basically starting the IoT Edge runtime on my local machine. I could do that on an actual device. And so what it does is basically starts a Docker container. So I can see that Docker container called Edge Agent, and I can look at its logs to see what's going on. And what should be going on is that it should be actually reading its configuration that says you need to have these two other modules, one called temp sensor and the other one called filter module. It happens so that it also starts another module called Edge Hub. In a nutshell, is getting the Docker containers from the various registries as defined in the configuration, and it will run them locally. So now if I do a Docker PS, I can see that I have 4 modules running. I have my agent, I have the temp sensor, and the filter module. The fourth one is called Edge Hub. That's the one that establishes the communication with IoT Hub and does the routing. So what's left to be done is eventually look at what's going on. So if I look at the temp sensor traces, what I can see is that this temp sensor is sending messages with a JSON that has a temperature with a certain value in there, right? What I can do also is visualize what's arriving in the cloud, because in theory, what should be arriving there is messages that have a temperature for the machine that is above 25 only, because that's what the filter module is doing. So messages are passed over from this temp sensor module onto the filter module. Filter module will detect only the ones, or will keep only the ones that have a temperature that is above a certain value, and will send them up to the cloud. So we can see here that we have messages arriving in the cloud from that temp sensor module that's been filtered by the filter module on my IoT Edge device. So you've seen how very simply I could actually do that deployment, everything with the Azure portal and some command lines. So you've seen in the demo how simple it is to prepare modules and deploy them on an IoT Edge device. So now if you want to learn more about IoT Edge, here's a couple of links. And if you want to take it for a spin, well, look at the various tutorials that we have on this URL here. And you can also revisit the various content that we have about Azure IoT Edge and Azure IoT in general on Channel 9. And thank you very much for watching this video.